Hey, sixth grade. Today in class we continued our talk about stars. We looked at another way that stars are classified. Two gentlemen that came up with a graph that's called the HR diagram. And when we looked at stars the other day, they were classified according to their temperature. In this diagram, they are classified according to their temperature and the absolute magnitude. So keep in mind those two factors as to how stars are classified through this diagram. We picked back up with some more characteristics of stars today and looked at what makes up a star. And it is like a cloud of gas and dust, and that gas would be hydrogen. And what we know is that the larger the cloud, the shorter the lifespan of the star. And the gas that we're looking at within this cloud is hydrogen. Now, what basically happens is that the hydrogen is being compressed because of gravity. So as that hydrogen is being drawn in, it begins to spin, causing friction, which produces heat. And that heat is radiated out as color, and the colors that we talked about the other day of the stars. The cool, temp, the medium, and the hot, those three. So in looking at the life cycle of a star, it begins with a nebula, which is a cloud of dust and gas. Now, as the hydrogen and the dust is rotating around, producing heat, and sometimes these temperatures get up really high. I think one place I read it was 15 million degrees. And as this spinning is going on with the hydrogen gas, it's also causing nuclear fission. So at some point in the life cycle, the hydrogen converts into helium gas. All right, so from there, the star becomes what is called a main sequence. And our sun is considered to be a main sequence star. Now, those stars that have a larger amount or a larger mass of gas and dust will eventually become supergiants. Those with less become what is called a giant. So we'll look at this side first. Main sequence will turn into a giant, and then a giant into a white dwarf. So first of all, in the main sequence star, the pressure is balanced from the fusion heating with the gravity. Then moving into a giant, I want to make sure that I give you the right information. As it becomes the giant, it expands and the outer layers begin to cool off. And then the helium, within it's converted, the nuclear fission goes from hydrogen to helium. In a giant star, then the core begins to form carbon, and then from there it becomes a white dwarf. It shrinks down to become a smaller, more condensed star. Now, for those clouds or stars that are larger, move into these are the massive stars, and the fusion is going on at higher temperatures. With a greater expansion, moves into what is called a supergiant. And then from the supergiant, the core collapses or crashes inward, it causes the outer part to explode, which is called a supernova. Then the core in the supernova collapses, which forms a neutron star. And then from a neutron star into what is called a black hole. And the gravity is so great within a black hole that not even light can escape it. That's all we're looking at today. What you're going to do is to take these notes and put them on slide 2 in your Google slide presentation that's marked lecture notes. And this is also in chapter 25 if you want to go and look at this information again. So we're looking at how the stars were classified according to the HR diagram, temperature and absolute magnitude, and then the life cycle of the star. Now, what I expect you to know is that we go from nebula to main sequence. The smaller masses go into a giant star and then a white dwarf. The larger masses turn into supergiants, supernova, neutron star, and black hole. If you have any questions or you need me for anything, please be sure to email me or send me a private comment in Google Classroom. Bye.